In this video, we're going to have a look at finding the rule for an arithmetic term without knowing the first term within the sequence if we know the location and the value of two other terms within that sequence. So in this example, the third term of an arithmetic sequence is -1 and the fifth term is 11. So we want to write down what the rule is for that arithmetic sequence and then determine the 50th term within that sequence. So to find the rule, when we don't have the first number, we need to go and do some additional calculations to determine what that first number is going to be. So because the arithmetic rule is similar to a linear line, and the calculations we used to do for a linear line is similar to what we need to do here. So the common difference that we don't know, because we don't have two consecutive numbers, we always said that that is like a gradient. So we can do a gradient calculation to be able to find what that common difference is. So to do that, I need two sets of coordinates if we're doing a gradient calculation. So I can write down the information that I do have. So I know the third number is -1 and the fifth number is 11. So I can use those two sets of values to go ahead and find the common difference. So remembering, if we were going to find the gradient of a number, back when we were doing linear equations, it's y2 minus y1 over x2 minus x1. So we can go ahead and our y values are going to be the second numbers, so -1 and 11. So I can go 11 minus -1 over my x values and keeping it in the same order. So I did 11 first up the top, so I'm going to do 5 first down the bottom. 5 minus 3, which is equal to 12 over 2, which is equal to 6. So I know, based on that calculation, that my common difference, or my d value, is going to be equal to 6. So I can put that into my rule that I know. So Tn is equal to T1 plus n minus 1d. So substituting that in and moving it to the front of the brackets, t to the power of n, it's equal to T1 plus 6n minus 1. So I'm trying to find my first value. So I need to substitute in values for all my other unknown terms. So I've got an unknown term t to the tn, and I've got the n term here. So to substitute values in, I can go ahead and use either of my original pieces of information, so 3 and -1, or 5 and 11. To avoid using negative numbers, I'm going to use 5 and 11. So when t to the power tn is equal to 11 and n is equal to 5, we can then substitute those values in, and 11 is equal to T1 plus 6 times 5 minus 1. So 11 is going to equal to T1 plus 24, because 5 minus 1 is 4. 6 times 4 is 24. So then finding out my missing variable by taking 24 from both sides, I know that T1 is going to equal to -13. So now that I've found that first term, I can go ahead and write what the rule is going to be. So Tn is going to equal to -13 plus 6n minus 1. So now that I've got that, I can go ahead and determine what the 50th term in the sequence is going to be. So when n is equal to 50, I can go ahead and substitute it in. So T50 is equal to -13 plus 6 times 50 minus 1. Putting that into the calculator, I get a score of 281. So the 50th term in the sequence is 281. So that's an example of how I can go through and determine the rule when I have two numbers within the sequence, but I don't have the first number. Then to be able to use that rule to go ahead and determine what a future value within the sequence is going to be.